The year was 1908. June 30th dawned like any other summer day in the remote Siberian wilderness, the sun climbing over the endless expanse of taiga forest. The air was still, the silence broken only by the chirping of birds and the rustling of leaves. Little did the Evenki reindeer herders, indigenous people who called this vast expanse home, know that the heavens held a spectacle unlike any they had ever witnessed. At 7:17 a.m. local time, an ear-splitting explosion ripped through the morning calm. The explosion, centered near the Podkamenaya Tunguska River in what is now Krasnoyarsk Krai, Russia, unleashed an unimaginable force. It was a cataclysmic event that would forever change the landscape and the lives of those who witnessed it. It flattened over 80 million trees across 830 square miles, a radius larger than the city of London. The sheer scale of the destruction was unprecedented, leaving a scar on the earth that could be seen from miles away. The shockwave, traveling at supersonic speeds, knocked people off their feet hundreds of miles away. The force of the blast was so intense that it felt as if the very air had turned into a weapon, striking down anything in its path. Windows shattered, dishes clattered off shelves, and the ground trembled as if shaken by a giant's hand. The noise was deafening, a thunderous roar that echoed through the wilderness and beyond. The explosion was so powerful that it registered on seismic instruments across Eurasia. Scientists were baffled by the readings, which indicated an event of extraordinary magnitude. Barometric pressure sensors in England, thousands of miles from the epicenter, detected the anomaly. The atmospheric disturbance was so significant that it altered weather patterns and was recorded by meteorological stations far and wide. Even the night sky, for several days following the event, glowed with an eerie luminescence, bright enough for people in Europe to read newspapers outdoors at midnight. This mysterious glow puzzled scientists and laypeople alike, adding to the enigma of the Tunguska event. The phenomenon was a stark reminder of the power and unpredictability of nature, leaving an indelible mark on the collective memory of those who experienced it. Accounts from the few eyewitnesses lucky enough to survive paint a vivid picture of the event's raw power. One man, sitting on his porch roughly 40 miles from the epicenter, described a fiery ball of light streaking across the sky, followed by a blinding flash and a wave of intense heat that felt like his shirt was on fire. Another witness, a reindeer herder tending his flock, spoke of the earth rising and falling beneath him, the trees around him snapping like twigs. These first-hand accounts, though fragmented and often passed down through generations, offer a chilling glimpse into the sheer terror unleashed that day. Despite the event's global impact, news traveled slowly from the sparsely populated Siberian wilderness. The first official investigation of the Tunguska event wouldn't occur until nearly 2 decades later, in 1927, when a Russian mineralogist named Leonid Kulik led an expedition to the region. Kulik, intrigued by reports of a mysterious explosion and rumors of a fallen star, set out to uncover the truth. What he found, or rather, what he didn't find, only deepened the mystery. Section 5. The scientific pilgrimage begins. Upon reaching the blast zone, Kulik was greeted by a scene of utter devastation. He found a vast area of flattened trees all pointing away from a central point, like a giant fingerprint pressed into the earth. However, he found no impact crater, no fragments of a meteorite, and no evidence of what could have caused such a cataclysmic event. The absence of a crater and any significant debris puzzled Kulik and subsequent scientists, leading to a flurry of hypotheses and theories. Section 6. The asteroid theory, a celestial visitor. The most widely accepted theory posits that the Tunguska event was caused by an asteroid, a rocky fragment left over from the formation of our solar system, exploding in the atmosphere. These space rocks, hurtling through space at incredible speeds, can release enormous amounts of energy upon impact with the Earth's atmosphere. The intense heat generated by this friction can cause the asteroid to explode before ever reaching the ground, creating an airburst with devastating consequences. This airburst theory explains the lack of an impact crater, as the asteroid would have detonated high above the surface. The blast wave from such an explosion would have been powerful enough to flatten trees and cause widespread damage consistent with the evidence found at Tunguska. Scientists have studied fragments and cosmic debris to understand the composition of these celestial visitors. By analyzing the data, they can determine the materials that make up these asteroids, providing clues about the early solar system. Computer simulations and scientific models help researchers predict the behavior of such impacts. Historical records and ancient manuscripts also offer insights into past events similar to Tunguska. These records, combined with global maps of impact sites, reveal a history of asteroid encounters with Earth. The asteroid belt, located between Mars and Jupiter, is a primary source of these space rocks. Telescopic observations from space observatories continue to monitor and track these objects. International space agencies collaborate to develop strategies for potential asteroid deflection. Futuristic technologies and missions are being designed to prevent possible future impacts. Protecting our planet from these celestial visitors remains a priority for scientists and researchers worldwide. The Tunguska event serves as a reminder of the powerful forces at play in our universe and the importance of continued vigilance and study. Section 7. The Comet Conundrum, a ball of ice and dust. Another prominent theory suggests that the culprit was not a solid asteroid but a comet, a celestial snowball composed of ice, dust, and rock. Comets, often described as dirty snowballs, are less dense than asteroids and more likely to disintegrate in the atmosphere. This disintegration could have released a massive amount of energy, causing the observed devastation without leaving behind a significant crater. Proponents of the comet theory point to the glowing night sky observed across Europe in the days following the Tunguska event. This luminous phenomenon, they argue, could have been caused by the dispersion of cometary dust and ice particles in the upper atmosphere. Section 8. Other theories, from the plausible to the bizarre. While the asteroid and comet theories hold the most sway within the scientific community, the Tunguska event has also spawned a plethora of alternative explanations, some more plausible than others. These mainstream theories are grounded in extensive research and data, making them the most widely accepted explanations for the mysterious event. However, the human imagination knows no bounds, and the Tunguska event has inspired a wide range of alternative theories that stretch from the scientifically plausible to the utterly bizarre. Some scientists have proposed that the explosion was caused by the sudden release of methane gas from the Earth's crust, a phenomenon known as a methane hydrate eruption. This theory suggests that pockets of methane gas, trapped under the Siberian permafrost, could have been released suddenly, causing a massive explosion. The idea is supported by the fact that methane is highly flammable and could create an explosion of the magnitude observed in Tunguska. Others have suggested that the event was triggered by a natural nuclear explosion, or even a collision with a miniature black hole. The natural nuclear explosion theory posits that certain conditions in the Earth's crust could have led to a spontaneous nuclear reaction. Meanwhile, the miniature black hole theory is rooted in the realm of theoretical physics, suggesting that a tiny black hole passed through the Earth, causing the explosion. Both of these theories, while intriguing, lack substantial evidence and remain speculative. Perhaps the most outlandish theory attributes the Tunguska event to an extraterrestrial spacecraft malfunctioning and exploding in the Earth's atmosphere. Proponents of this theory argue that the lack of a crater and the unusual patterns of tree damage could be explained by an alien spacecraft disintegrating in midair. This idea, while captivating, is often dismissed by the scientific community due to the absence of any tangible evidence supporting the presence of extraterrestrial technology. This theory, while lacking any concrete evidence, has captivated the public imagination and fueled countless science fiction novels and films. The notion of an alien encounter gone wrong has provided rich material for storytellers, allowing them to explore the boundaries of human creativity and curiosity. Whether through books, movies, or television shows, the Tunguska event continues to inspire and intrigue, reminding us of the enduring power of mystery and the unknown. Section 9. The Tunguska event's enduring impact. The Tunguska event, regardless of its ultimate cause, stands as a stark reminder of the power of nature and the inherent unpredictability of our universe. It highlighted the very real threat posed by near-Earth objects and spurred scientific efforts to track and potentially deflect these celestial wanderers. The event also had a profound impact on the local Evenki people, who lost their reindeer herds, their homes, and in some cases their loved ones. the event became entwined with their folklore, a cautionary tale passed down through generations. Section 10. A century of speculation, a universe of unknowns. Over a century after the Tunguska event, the mystery of what transpired above the Siberian wilderness that fateful morning remains unsolved. Despite numerous expeditions, countless scientific papers, and decades of research, no definitive explanation has emerged. The Tunguska event serves as a humbling reminder of the vastness of our universe and the many secrets it still holds. It reminds us that for all our scientific advancements, we are still vulnerable to the whims of the cosmos. Section 11. The Tunguska Legacy, a reminder of our cosmic vulnerability. The Tunguska event, while a distant event in both time and space, holds profound relevance in today's world. It underscores the importance of continued scientific research and international collaboration in monitoring and mitigating the risks posed by near-Earth objects. It serves as a reminder that our planet, for all its vastness, is but a small and fragile oasis in the vastness of space. The Tunguska event, a century-old mystery, compels us to look up in wonder, but also in caution, at the celestial tapestry that surrounds us.